Alright, so we're going to go over your assessment that you took. It kind of covers everything with exponents and exponential functions. So the first thing I want to point out is that on number 1, it is a subtraction problem. It is not multiplication. So I did see a lot of people take a squared and make it a to the 4th. That would only happen if this was multiplication. Since we are subtracting, you are doing a squared minus a squared. When you do a squared minus a squared, this makes 0. So you actually end up with none of these. When you do b minus b, you end up with no more. Negative 7 minus 2 is negative 9. It's really important that you understand the difference between subtraction and multiplication, because otherwise you're going to end up making the error that you did with the variables. On number 2, this is all multiplication. X times y to the 3rd times, and then I'm going to have to distribute this exponent, so it's times x to the 4th times y to the 4th. Since this is all multiplication, that exponent law where you add the exponents does apply. So if you have x to the 1st times x to the 4th, that's like having x times x times x times x times x. Therefore, you have x to the 5th. This would be y times y times y times y times y times y times y. So you have y to the 7th. Number 3, you've got a power to a power rule, so you're going to have to do 3 cubed, and then x squared cubed, which would be x to the 6th, and then y to the 6th. This is where most of the errors came from. 3 cubed is 3 times 3 times 3, which would be 9 times 3, or 27. Number 4, this is division. So when you divide this, you end up with 1/4. When you divide your x's, you end up with 2 x's on top. When you divide your y's, you end up with 1 y on bottom. Number 5, I think it's best that you make a table first, so that way you can then graph appropriately. So in your calculator, you can put in 4 to the x and get your table. So we've got negative 2, negative 1, 0, 1, and 2. That's how I like to start. 0.0625, 0.25, 1, 4, and 16. Now I can graph. So I've got negative 2 and then barely above it. Negative 1 and 1/4 of the way above it. 0, 1, 1, 2, 3, 4, 1, 4. 2, 16 would be somewhere way up here. So you're looking at that. This would be growth. Our b term is bigger than 1, so that's another indicator that it's growth. My domain, because this continues on forever left and forever right, my domain would be all real numbers. My range, if you notice in the table, it never gets to the 0. This would be scientific notation. So this is like 0.00098, 0.00024, 0.00061. So it's getting smaller, but it never actually reaches 0, which means all of my y's are bigger than 0. They're not equal to it, though. It crosses the y-axis at 1, which makes sense because my a term is 1, and a is your starting point, and another word for y-intercept is starting point. The asymptote is that barrier that it never crosses. Well, we already identified that it's never going to get to 0. It's going to get close, but it's never going to get to 0 on the y. So my asymptote sits at y equals 0. So it actually sits directly on this x-axis. Number 6, I can already tell this is decay because it's less than 1. Let's get a table out of this. So you can change this to 1/3, get rid of my 4. And now let's look at that table. So you've got, I'm going to do negative 2, negative 1, 0, 1, and 2 again. 9, 3, 1, 1/3, and 1/9. So I have negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 3, 0, 1, 1 1/3, 1 1/9. So again, it's going to get so close to that 0, but it's never going to actually be that 0. It is going to continue going right forever and left forever. So my domain is all real numbers. Because it never reaches that 0, but it does go all the way up forever, all of my y's are bigger than 0. My y-intercept is 1, which makes sense because my a term is 1. That's my starting point. The asymptote, since it's never going to reach the 0 on the y-axis, so here's 0 on the y-axis, here's 1, here's negative 1. So you have negative 1, 0, 1. This is 0 on the y-axis. So my asymptote is y equals 0. So that's the front. You can go back into homework check to check the back.